All right, guys, welcome to the volcano video. So the way we're going to do homework tonight is you will write notes with the video so that you're prepared to come to class on Wednesday or Thursday when we talk about it. And then also there are seven questions throughout the video that you will need to answer. All right, so first thing is first. What is a volcano? So a volcano is a vent in Earth's crust through which molten rock flows. All right, and so there are several different ways that these are formed. So two of the ways, and right here, this is the most active volcano currently in Hawaii. And no, I do not know how to pronounce that. All right, so how do volcanoes form? Well, we have most active volcanoes form at convergent continental oceanic crust plates. And so what happens is the dense oceanic crust goes underneath the continental crust, and when that crust goes down, it melts into magma, and then through cracks in the continental crust will form a volcano. Another way they form is through divergent boundaries. So the mid-ocean ridges is an example of that. And so that is where the magma spews out of the mid-ocean ridge, and the two plates will go separate ways, so that the youngest rock is at the ridge and the oldest rock is at the shoreline. And last but not least, there is hot spots. So Hawaii, for example, is not near a convergent or divergent boundary. In fact, it's in the middle of a tectonic plate. But the reason why Hawaii is formed is because there is a hot spot. So what happens is this hot spot stays there, and it's just where there's a lot of magma, a big magma chamber that's built up. And what happens is the hot spot stays in its place because it's in that asthenosphere. However, the plate above it continues to move, as the plate boundaries always do. And so the island right above the hotspot is active, but these guys are already dormant because it's not underneath the hotspot any longer. It's moved. So question number one, is the plate below moving towards you or away from you if you are standing on Hawaii? So is the plate itself moving away from you, or is it moving towards you? Okay, so that's question number one. Question number two is, where do volcanoes form? All right, so the area of earthquake and volcanic activity that surrounds the Pacific Ocean is called the Ring of Fire. And the reason why it's called the Ring of Fire is look at all these active volcanoes that surround the plate boundaries. And there are a few volcanoes, of course, inside the Pacific Ocean as well. But volcanoes mostly occur at convergent boundaries, and that's what all of this is. We have oceanic plates converging with those continental plates. So question number three is, where would active volcanoes most likely form? Where would they most likely form? All right, so volcanoes in the United States, there are actually about 60 volcanoes. Most of them are part of the Ring of Fire that we just looked at. And the USGS monitors earthquake activity changes. They watch the volcano very closely to make sure that those around the volcano are protected, okay? So like here, they're living by a volcano, but it might be dormant. But they do need to make sure that it doesn't become active. So that's what the USGS does for us. So volcanic mountains, what you see 4 volcanic mountains, and that's formed whenever molten rock erupts onto Earth's surface, and then as that cools, as it forms into igneous rock, it creates these volcano shapes. So there are 2 different types. There are shield volcanoes, and then there are composite volcanoes. Shield volcanoes come from divergent boundaries, hotspots. They are not very explosive, and that's why you have that gentle slope. However, composite volcanoes are definitely explosive. They come from convergent boundaries, and they can definitely be on the dangerous side. The cinder cone volcano in the caldera, that's after a volcanic eruption, so that's just kind of what happens afterwards. All right. So, volcanic eruptions, there's really two. You got the really violent explosion, eruption, where it will send ash into the air, tiny particles of pulverized rock and glass. And then you have the quiet eruption, where it's just kind of seeping downwards. It's seeping outwards. It's not a huge explosion, the way you see down below here. And why is that? So the reason, there are actually two reasons. So it's really all about the chemistry of magma. So silica is a chemical compound found in magma, and it determines the thickness. So thickness is a fancy word for thickness is viscosity. So viscosity is the liquid's resistance to flow, but that's basically just the thickness. So if you have a low silica content in the magma, you have low viscosity, which means it's not that thick. Think like on your pancakes Saturday morning, you heat that syrup up about 30 seconds, you get that perfect warm maple syrup on your pancakes. That's kind of like low silica, low viscosity. And so when that happens, you have that fast rate of flow. Well, the reason why you get these explosive volcanoes is because there's gases in magma that need to essentially escape. Well, in the low silica, that magma, since it's very flowy, those gases can escape very easily. However, in high silica, high viscosity, super thick, sticky toothpaste, you get that slow rate of flow. Well, those gases build up inside the magma, and then all of a sudden, when it can't take that much pressure anymore, so then that's where you get those explosive eruption. You get the pyroclastic flow and all that stuff. So if you have, here's question number 5. If you have a high silica content, high viscosity, what type of volcano will it produce? An explosive or a quiet eruption? And how, question number 6, how does the amount of silica change the viscosity of magma? So how does it change the viscosity of magma? So that was questions number 5 and question 6. Bell's about to ring. We're almost there, though. All right, there it was. I'm about to kick my 4th hour out. All right, so effects of volcanic eruptions. So we have lava flows. Check this out. This is low silica, but you would get this magma flow. Check that out. Just crushing that can. All right, pretty sweet right there. And then we get the pyroclastic flow. Now this is just fascinating. Absolutely fascinating. Shh, quiet.
Something triggers a pyroclastic flow about 10 times bigger than all that came before. Within moments, it overwhelms the valley.
So that was literally the pyroclastic flow, just ash, dust, and it's so powerful that it can knock down trees. It is extremely powerful. That comes from explosive volcanoes. And last but not least, we have some mud flows. Now, on a positive note, though, the rock and soil are enriched with valuable nutrients when these volcanic eruptions occur. So the last question is, what are the positive results of volcanic eruptions? See you tomorrow.